Topics covered in probability. We will start by establishing a strong foundation with fundamental terminology, ensuring you are comfortable with key concepts such as experiments, outcomes, sample spaces, and events. From there, we will learn to distinguish between theoretical probability, which is based on mathematical reasoning, and experimental probability, which is derived from observed data. As we progress, we will master the essential rules of probability, specifically the addition and multiplication rules, to calculate the likelihood of compound events. We will also delve into more complex areas, such as conditional probability, where we analyze how the probability of an event changes given the occurrence of another, and the concepts of independence and dependence, which help us identify how events relate to one another. Welcome, everyone. Today, we are beginning our exploration of probability. This first slide serves as our roadmap for the upcoming lessons. Mastering these mathematical foundations is essential, as we will soon see how these very principles are applied to real-world scenarios, ranging from medical advancements to the logic behind artificial intelligence. Real-world applications of probability. Now that we have explored the fundamental rules and terminology of probability, you might be wondering how these mathematical concepts are applied outside of the classroom. In this slide, we will look at the real-world applications that make probability such a vital tool in modern society. In the fields of science and medicine, probability is essential for determining the efficacy of new drugs through clinical trials, and for modeling how diseases spread through a population. Moving to finance and economics, professionals such as actuaries use probability to assess risk, which allows them to set insurance premiums and predict fluctuations in the stock market. Even in meteorology, weather forecasting relies heavily on probabilistic models to calculate the likelihood of precipitation or the occurrence of extreme weather events. Finally, in the realm of technology, modern computing, ranging from search engine algorithms to the advancements in artificial intelligence and machine learning, is built upon probabilistic logic to recognize complex patterns and make intelligent predictions.